All right. Thank you, everyone, for tuning in today. Thanks to all the folks at Pulumi for putting this on and having us here. Really excited to talk about building self-service clouds and what we've been working on at MBRDNA here in Seattle. My name is Carter Williamson. I'm a senior infrastructure engineer at the MBRDNA Seattle Hub. I've been with the Hub for about 2 years, and the majority of that time has been working on this product, this self-service cloud that we've been building. So a brief bit of background before I get too far ahead of myself. The primary focus of the Seattle Hub is to build the future backend for the connected car in the cloud. So this involved a two-pronged approach of both migrating existing services out of a data center into the cloud without having to re-architect the services themselves, while simultaneously enabling teams to use cloud-native solutions and building new services and applications. We went through quite a few different iterations on how to quickly build infrastructure and automate infrastructure for different engineering teams. The solution that we ended up landing on is what I'm going to be demoing today, and that is our infrastructure portal. So we wanted this portal to really be something that kind of acted as a kickstart to get teams, focused on their application and their service development, and give them a place just to run their code as quickly as possible without them having to take on the overhead of understanding all the different details and bits and pieces required to set up their runtime in an environment on the cloud. Additionally, this is a nice centralized platform for us to apply and kind of manage some global policies as well as provide some best practices for development teams. So without further ado, I'm going to go ahead and show this demo. So I'm going to flip over here. So this is our current portal. This is, as you'll notice, this is a little different from what we saw on the slides. The screenshot we have there is our new beta portal that we're in the process of developing. For now, I'm just going to show what we have existing. You can see there's a couple different types of deployments that we provide for teams. The kind of core piece here is this environment, which is just a generic. It spins up a number of resource groups with some network connectivity and a Kubernetes cluster for teams to run their containers in. So go ahead and hop into here. Oh, timed out. So I'll just log back in. All right. So I'll come in here and I'm going to go ahead and add an environment. So I'm just going to fill out a couple things in this form here. I'm going to call this demo 1. Go ahead and find a group in here that I can use. And we'll just set a development here. And we'll just say, we'll have it expire tomorrow. So you can see here we got some details around what will actually be deployed and some kind of general cost guidance around those as well. We have some additional pieces here for more advanced users and then some tagging as well. So I'm going to go ahead and just fill this form out real quick. And I'll just say, let's call this development, test project, self-service portal, and we don't have to fill those ones out. So cool. All right, so that's it. I filled out my form. I can click save. It'll give me a quick pop-up to confirm that I actually do want to create this, which I do. All right. So in the background right now, what it's doing is it's reaching out to the Azure DevOps pipelines and kind of kicking off a build there where our pipeline will run, do some configurations, some kind of setup stuff, and then it will eventually run some Pulumi code, which will spin up our resources in Azure. After Pulumi's done, there's some kind of post steps that will install some Helm charts as well as a few other things, and then finally, it'll validate that the network connectivity between our internal network is working properly. So this will take a few minutes, so I'm going to briefly pause here and switch back to our slides while that's running. So while that's building in progress, I want to talk briefly about kind of our organization's approach to operations and managing the infrastructure. Our team is pretty small, so we don't really have the capacity to manage and operate these all these clusters floating around in our cloud. So what we're doing is we're decentralizing our operations, and our team is acting as a centralized automation team where we can provide automation and environments to other teams that they can then manage as part of their own pipelines and their own processes. Part of that is providing Pulumi code. We also use the Azure SDK and some other Python tools, as well as Azure CLI and various other tools depending on what the platform we're targeting with our automation is. So what I want to show next, after our build is complete, is how do we hand off the Pulumi automation to teams. This was a big request after the first initial round of environments were provisioned. We started getting teams coming back to us saying, great, but now I want to manage this as infrastructure code. We want to own that Pulumi code, essentially, which is great, and we were really encouraged to hear that teams really want to take the ownership of their environments to that next level and being managed with Pulumi. Okay, so I'm going to switch back over to the portal now. The build should be done now. Yep. So we can actually go ahead and go to our Azure portal here and get an idea of what this looks like when it's all complete and when the automation is finished running. All right, so here we can see all of the resource groups created by this automation. We have our Kubernetes resource, LA workspace, which is for logging and monitoring. So we set that up and we attach it to AKS automatically so that when teams come in, they immediately have access to their Kubernetes logs, and then they can pipe out their custom logs through that same interface. And then we have our kind of core pieces. This is just networking. So if we dive into here, we can see that there's a VNet and a route table, and there's some subnets attached to this VNet. And then the resource group created by the Azure Kubernetes Service Managed Service provider, which actually contains information and resources about the nodes themselves for the Kubernetes cluster, as well as load balancers, IP addresses, security groups, etc. So coming back to the IDCA portal here. So what we were talking about before coming back here is the idea of wanting to give teams a way to manage their Pulumi code. So we've added this Manage Infrastructure as Code button here. So what this will do is we click that, and it's kicking off a pipeline that is running in the background and doing some initial setup. It's pulling the state from the provisioning that we just did as when we were building this, and it's setting up a new project and zipping it up into a nice folder that then we can download from here. And what this is doing is really giving the end user a way to just grab on to their Pulumi code, their Pulumi state, the resources that are already provisioned, and essentially copy that into their own repository and then take over management. The downside to that is this creates potential for user error. When we export the Pulumi code, teams could potentially modify the address space configuration value and not only misconfigure their own environment, but possibly start overlapping with other environments and creating conflicts. To counteract this, we've set up Pulumi in such a way that depending on some runtime parameters and configuration values, we can tell if our team is running this through our pipelines or if the code has been handed off to the development team. If the code's been handed to the development team, their virtual network and address spacing and all those resources that we want to hold some control over, they will see those as a read-only resource. So they can interact with it the same way you would interact with any other resource in Pulumi, but it will also just not actually pull in that resource as a managed resource in their state file. Great, so it looks like that process is finished, so I'm going to click download. This is going to pull down a tarball that will have some scripts and Pulumi YAML files, as well as requirements txt for pulling in different Python components and packages. All right, so I'm going to unzip this. So we can see we have our main.py. That actually contains our Pulumi code, and I'll show this in a moment. We have our Pulumi config, our Pulumi config value, config file here, as well as README with some instructions for initialization and our initialization script. So I'm gonna go ahead and move over to my terminal here, and we can see what this looks like. Open this in VS Code. We can take a look here. So we've got our README here. So I'm going to go ahead and walk through these instructions quickly. But essentially what this script is going to do, the initialization script, is we're going to set up some rules and permissions for user access to ensure that we have everything set up correctly, so when the users go to run Pulumi up after running this initialization script, they'll be 100% ready to go out of the box. They don't have to go to Azure and set up any roles or configure their service principal. We've taken all that and just put it into a small little bash script. And this will include setting up the Pulumi state and Pulumi stack in the SaaS backend, or locally if the team doesn't have backend configured already. Okay, so let's run this real quick. So I'm just going to run this script. I've already set up some environment variables to identify my service principal and logged in with the ACCLI. And here we go. So this is actually setting me up and giving me the appropriate access to our local encryption key. That's a cool feature that we've started using recently with Pulumi, is the kind of bring your own key methodology. So that allows us to have a key vault where we can manage access and who can access that key and who can read it and who can update it. And that is then our encryption key for our Pulumi state and our Pulumi secrets. So while this is running, I'm going to head back to our slides here briefly. So why is this important, this process of being able to hand off the infrastructure as code? It's really driving towards an end goal where we have infrastructure and application delivery in a blended way. So using Pulumi to do both your infrastructure provisioning as well as deploying applications and services through Helm charts, setting up databases to integrate with those, creating secrets and passing those into a key vault. There's a number of different ways that you can integrate Pulumi with your current CI/CD process that really allows this kind of blended infrastructure application deployment process. And so that's really the goal. First step is provision infrastructure, get the code over to the teams, then they can decide to what extent they want to add on new resources or integrate their CI/CD process with the Pulumi stack that we've handed to them. Some teams prefer to just keep Pulumi as their infrastructure component, infrastructure management component rather, while still using tools like Helm to deploy. Other teams really like to have everything kind of under one umbrella, and that's a great chance for them to use Pulumi. Come back over here, and so now, after that's been ran, we should be able to run Pulumi up. Whoops. Yep, looks like I forgot to activate my virtual environment, so just do that real quick. Okay, and let's try that again. Pulumi up. So we've already set up their stack. We've already selected the stack, imported the resources, the config. So at this point, the developers just had to click a few buttons and run one script, and they've been set up. Cool. So we can see that there's really no changes here. It looks like there might be a provider update available, but we'll just go ahead and ignore that for now. Yeah, so I'm going to go ahead and I'm going to skip this update for now since there's no real changes. And let's do a quick demo on what that will look like if we want to, say, add something else here at the end of this, right? So, for example, let's say that this particular application, maybe they need a Postgres database. So let's add one of those in. So we can do Postgres DB. Actually, we'll need a server here. And I actually have these this code saved on a different buffer here. So I will go ahead and just copy this in to save us some time. And so I'll walk through this briefly. 1 second to set this up. Oops. Okay. So what we're doing here is we're setting up a resource group for the Postgres server to go in. We're going to generate a random password using Pulumi's built-in random passwords library, and then we'll set up a server as well. Additionally, we could set up more databases attached to the server right here, but for simplicity's sake, I'm going to go ahead and just show you this as it is. All right, and Pulumi up. We should see those changes come up here in just a second. Then we can apply those and we'll start building our server. So this is a great example of, say, an engineering team who has a requirement they need a Postgres server alongside their application for it to run properly. This is a great example of how that can just be integrated into and expanded upon our environment template. This is the same concept works for adding column charts and other deployment pieces. So I'll just go ahead and apply this change. Okay, and I'll go ahead and navigate over here. We should see the resource group is populated here. Just a second. Let's grab the name of that. There it is. And we can see that this is still in the process of creating the Postgres server here. That'll take a few minutes. So without making us wait for that, let's jump over to our slides. So then looking beyond just the core infrastructure deployments, we see some real benefit around using some of the providers Pulumi offers, and especially around monitoring and dashboarding as code. This is really critical for us to manage our operations components, and being able to provide kind of out-of-the-box base level of some sort of health checks, monitoring, dashboards is critical for us. And on the right here, you can see an example of not only how we can utilize the kind of native class structure of Python to abstract away the little detailed components, but also this is a rough outline of how we can integrate with Datadog so that when an environment goes out, you can simply call this function and it will provision integration with, in this case, PagerDuty. There's another great example here that we actually use for this service. I'll show you this here. So this is actually part of our provisioning. This sets up our alerts. So what you can see here is that we're using some of the built-in components from the Pulumi's Azure provider package. So this is setting up an action group. This is really nice because we can build in our OpsGenie, in this case our OpsGenie webhook, as well as some email receivers so we can follow up with some emails. This is just kind of to show that you can use multiple different approaches to alerting, but you can still wrap them all up nicely in just one little class. So here we've got a list of different alerts and some of their thresholds and severities. Again, instead of creating a custom block of code for each individual metric, we can just kind of outline them as a dictionary and loop over them and instantiate them as we go. This particular use case is an interesting study because one of the limitations of application insights is that you aren't able to create an alert on a custom metric until that custom metric has been initialized or has the first instance of that metric has been pushed into application insights. So this would have been a pretty big challenge for us in the past. Luckily, we were able to just add a quick little function here that will hook into the actual Azure SDK telemetry client for application insights. And all we're doing here is we're just calculating the threshold minus 10 so that we're not initializing this over the threshold of our alert. And then we are just sending that metric just below the threshold with some just kind of filler values to get those up there. And then after these have been initialized, we can easily create the resources using the native Pulumi provider. This kind of practice really improves the integration between development and operations and infrastructure. Tying all those things together in one platform and one code base really has made our lives a lot easier in kind of dealing with this sort of challenge and problem. And we have a few minutes here for some Q&A. So feel free to ask any questions about Pulumi, about Mercedes and how we're using Pulumi. Really anything around infrastructure automation, we'd be happy to answer at this point. And with that, I'll just say thank you. And we appreciate, again, Pulumi, thanks for having us. It's been great working with everyone on this project and sharing this journey with the Pulumi team. And on behalf of MBRDNA, I'd like to extend a congratulations to Pulumi for their 2.0 launch.